Hi, my name is Tamegoda. I'm gonna show how to create a how to train machine translation model with one of my neural machine translation toolkit named RTG. Let's get started. So the documentation is at QTLab name /RTG. Here there is there's plenty of documentation, but the important one is right now. If there is a Google Colab example, which was created a few years ago, let's get started there. Um, it's probably outdated. So I'm going to, this is unscripted video, going to do it like how it is done in real world. So no scripting, nothing. I might get stuck. I'm gonna record everything. It's probably boring. I'm gonna do it anyway because I have to do it for a project. Okay, so here is an notebook on Google Colab. I created it a long time ago. So let's see if I need a GPU. I'm going to try running it and see if I have GPU. So if you see, it is initializing right here. It's connected. Okay, now I see I have a GPU, which is a Tesla T4 with 15 GB. Okay, that's a good one. Next, before I train a model, I'm trying to figure out what kind of resources I have. I have a GPU, and now I'm going to figure out my environment and set up. The first step is setting up. So what version of Python I have? Um, oops, Python is not defined. That is weird. Oh yeah. So this is not a bash shell. This is Jupyter. I have to put a exclamatory mark. Okay, I have 3.7. That's good. Going to install RTG, which can be installed using that command pip install RTG. As you can see, it is getting 0.7. Um, okay, it is downloading PySpark, downloading Sacre Blue. Guess it's gonna download everything it is required, so we just sit and watch. Torch, TensorBoard, YAML. Still building, still installing. Okay. Still installing. Okay, successfully installed. I think this documentation, this notebook was created many years ago when the Google itself was not using Python 3.7. The Colab was not 3.7, so I had to do some hack to get 3.7 working because 3.7 is required for RTG. So now this is 2022 September, 3.7 is supported in Colab. So I don't need this section. I'm going to get rid of it. Yes, I don't need this hack to get 3.7 working. That was done a long time ago. All these, again, this is all automated now. Now, if we just do, as we saw, pip has already installed PyTorch. We didn't have to install it. Previously, it was not automated. Now, it has already installed all the libraries we need. So just making sure I have Torch, which is 1.12. Okay, that's good. Next, I'm making sure if my RTGPipe, the command that I use for training the model, is working. As you see, it is working. The next thing I want to make sure is making sure that Torch is able to see GPUs, and uh, it used to be a big issue before that because of NVIDIA CUDA mismatch. So we need to get CUDA driver, CUDA SDK, and all this, and Torch compatibility, everything working. So what I'm going to do is import Torch and then verify if CUDA is visible. Oops, it recognizes this as documentation. I need to I need to add a code cell. Okay, here. Import torch dot CUDA dot is available. That should show, yes, CUDA is available. That means CUDA backend is properly configured. That's good. Now the installation is set up. So to summarize, I know we have a GPU. Then we have installed PyTorch. We have installed RTG and its dependencies, and we verified that PyTorch is able to see GPU. Okay, the next step is to train a machine translation model. We need to download data sets. So for that, I have another tool named empty data, and I'm going to going to see its documentation, and let's see. Maybe I'll get a command to copy paste it to download data sets. There is no, as far as I know, there is no ready to download a zip file where you can extract and train a model. So we need to create data sets ourselves. So here is a tool called empty data. I'm going to check if empty data is available. Here, let's add a code snippet here. Okay, cool. Empty data. Is empty data available? So no, it's not available. So I'm going to install it. Pip install empty data. Okay, great. Next, I need to download a data set for training machine translation models. Now, if I keep scrolling empty data documentation, here I see a quick start example. So I'm going to copy paste this quick start example. If you notice, I already had this in my outdated notebook, but as a developer of empty data, I know the empty data backend has changed. So this is not going to work. For example, I'm going to show it to you. Yes, so I have to get the updated documentation, or I have to fall back to the older empty data. So since I just installed an updated empty data, I'm going to use an updated command, which I copied from empty data readme file under quick start, our example. So here we go. This is also a shell command, so going to add bash annotation so Jupyter knows it is shell. Now we just sit and watch. Because downloading this data set would take some time. I wish there was another way of monitoring logs other than sitting and waiting. There's nothing else I can do right now. Oh, probably I can browse file system and then see if there is anything getting created. So yes, I created a directory called, if you take a closer look at this command, we have empty data get -l is a language. I'm specifying DEU English, German to English, and output under data/DEU English, and then merge all these data sets. These are the training data sets. I have Europol and news commentary, and this is the dev data set, and these are the test data sets. So I specified it to create data DEU English. As you can see, it's creating files. Usually, empty data prints out log. I can say that confidently because I created empty data, but here we are not seeing the log. I think that's because that's how Google Colab or Jupyter is configured. But I can tell by looking at these directories that it is downloading files, and we just have to sit and watch. And this revolving circle means it's still downloading. We might, if my guess is right, we will see a huge chunk of logs once the command finishes. Okay, while it is downloading, I'm gonna do some cleanup on this notebook, the old notebook. So I just mentioned that this is an outdated command. We no longer need it because I have a newer command up. And we will do this, data slash, okay, there you go. So we see a lot of logs, and then in summary, downloaded it. I think we have good enough data. It has selected 2.2 million sentences. Now we can look at this data, and then we know there is train.du, train.eng. So these are German and English train data. Then test 1, test 2, test 3, then dev. So, okay, this is all created. Now I can do data slash du in, just taking another look at the data, showing it here. Yes, it has downloaded all this. Let's see if I can run a tree. The command not found. That's too bad. Okay. So we know the data has been downloaded. Next part is now creating, let's see what this is doing. Let me read this. Renaming files, ls tests, move. Okay, so it is simplifying some file names. Again, this is done with the older version of empty data. And now I have automated all these things. So what this section of code is doing, it's going inside the test directory and then creating simple names for this. So if you notice, I already did that. The empty data command is already doing that. So we have simple names, test1, test2, test3, dev, for example. So we don't need this block. So I'm going to remove that. The next section is tokenizing. So again, this command is outdated. D is data den. It's actually now data dueng. Then within that, I have trained, and then tests slash du and dev $d. So we need to, let me take a step back and explain. We need to run a word tokenizer that separates words from punctuations. That's helpful to learn better byte pair encoding that we're going to do later. Okay, so that is, look at this line 4. Maybe let me zoom in. Okay, so line 4, going inside this directory, that's the train file, many number of held out test sets, and then one dev file, and then we are checking if this file already exists. The tokenize f.tok already exists. If it exists, then skip. Otherwise, we're going to use Saccharomyces to tokenize. Okay, and the same thing with the test. And dev. You know what? I can just do a star. Didn't have to do this. Star.ing, star.dev, star.deu. Okay. So we're going to run the tokenizer. Hopefully it works. Now we should see on this left pan, we are only seeing the files ending with .du and .eng. After running this, we should see .tok, meaning tokenized. Okay, we see some of the TOK files are getting created. Again, we're not seeing the outputs in real time from this Jupyter notebook. So let's wait for it to create all the tokenized files. That should take some time because the data is somewhat huge. I'm not playing with some toy data set. This is a real data set. People used to train real machine translation models. As we saw here in the top, when I downloaded data sets, it printed that we have a total of 2.2 million sentences. So there you go, that's our scale. So I think 1.8 million sentences are from Europol dataset alone, and 388,000 sentences are from news commentary. Okay, let's take a look again. If it's still running, it's gonna take some time. You sit back and relax. Meanwhile, let's see what else is coming down. Now we have to prepare an RTG experiment. Okay. We need to prepare an experiment. So let's go back to utlab name /RTG documentation. Okay, so here is a conf. The key example here is we need a configuration file. We need to create a configuration file, rtgconf.yml file. There is some documentation explaining what goes inside, but since I'm making a video and don't want to take too much time, I'm gonna take you directly into the solution that we are looking for. Let's go inside the Git repository, which is publicly available. Now, if we look at experiments, then we have some config files. There is transformer base.yml. So this is a sample config file. What I'm going to do is use this. So this is my config file, and we look at it. It already has all the configurations except some assumption about where the data should be, training data, validation data, etc. So I'm going to modify these paths because now we have different paths. Okay, so let's get back to our notebook and let's see if it has finished. Nope, it's still tokenizing. Let's see if we have tokenized. Dev is tokenized. Dev English is not. Test is tokenized. Test2 in German is tokenized. Train.bu. So German tokenization is still running. Okay, that is going to take some time. Maybe I should have parallelized. So here we see we have 2 CPU cores. Yes, we only have 2 CPU cores. So it is going to take time because of 2 CPU cores. Here I have already given 4. Ideally, we would go and get a coffee this time. Maybe I should do that. Okay, I'm going to pause and re-record it later once this finishes. So where were we? We were tokenizing our data. It took some time. Now let's take a look. We see .doc files. So let's run a data /tueng. Let's look at the doc files. Yep. So we see train, test, dev. Okay, all good. Now the next step. Now that I know I tokenize the data, which is a word level tokenizer. I'm not sure if I will be able to open one of these and see. I don't think so. I have to download it. Okay. I would usually look into these files and see everything is fine. Next step is preparing an experiment. So we have been preparing an experiment so far, but now what is more is an experiment consists of uh, a configuration, bunch of hyperparameters. So in RTG framework, it means I have to prepare a configuration file that has everything required to say about this experiment, which usually it is an YML file, a directory for experiment, inside that a conf.yml. So I'm going to prepare that. So here is an example configuration file. Going to download that from here, replace that. So I'm going to make an experiment and then paste configuration file into it. Okay. That should be done. Refresh. Yes, so I see one TFM German English, and then there is a conf file inside it. And now the question is we need to edit this configuration file and mention where our training and test sets are. So test, let me put this path. Test train source is now data slash DUENG train. We're going to train from German to English and not the other way. Data slash, if you look at this on the left side, our directories are organized this, and we need to specify the paths, and test directories are in validation data is also in the same directory. Okay, let me call it data directory. Data directory is this, data slash this. Now F. Okay, it's going to take some time. Let me do this proper way where others can reuse this notebook if they want to. Of course, I'm doing this because it's a notebook. If it was in a bash shell, I would have opened an editor and then edited it. But again, if I do that, then it's not reproducible because now I have to tell others to edit this. Okay, so dev English took. Sorry, source is DEU and validation target is English, and we are updating the config tester. We have test one. Okay, what are we doing here? Okay, so data directory slash, let's call it dev. Let's put the dev set first. dev.du.toc. This is the most time consuming part. Rest everything would be automated. Once we have created the configuration file, you will see that it's really, just sit back and watch once you have the correct configuration. So with this toolkit, even though you might feel like I'm spending much time messing with this configuration file, once we have done that, it's really just one command to train the whole model. Test one. So what am I doing here is I'm updating this. Let me take a step back and explain it. So this is our configuration file for an experiment. It has most of the values filled in, but the paths need to be updated. So we are updating train validation and then some of the paths here. Okay. And I have to do it in a notebook way where others can also get done automatically for others. So I'm writing Python code instead of manually editing the file and uploading it. Test one. Test two. test 2. Okay, now I can remove these sections. Okay, let's look at what we have here. So here in source, target, both are tokenized. In tester, in suit, we have data directory. The source is tokenized. The target or the reference is not tokenized, as you see .eng, and that is very important because we need to report we need to evaluate against unmodified references. Then we're going to train for say 40,000 steps, and batch size of, we have a lot of data here, so but I also want to finish the video quick, so I'm gonna put 4,000. Ideally you should pick a bigger batch. Then we are updating the config file. Let's see what else we need. Okay, this is our updated conf. Now we're going to load TensorBoard. It will get created. Right now it is not because I haven't started it. Now I'm going to run our RTGPipe. As you see, it's really one command. So once we have a configure experiment directory set up, which is this 01-tfmden, and we have configuration file in it, which is the one we have created, then we just call it RTGPipe and it will run it for us. Okay. And as you can see, I also explicitly said GPU only, so it must use GPU or crash if it's not able to use GPU. Then it is creating the vocabulary. You might be wondering how many vocabulary types. We have 8,000 types, but the data is 2.2 million-ish, over 2 million, and it is using sentence piece under the hood. In the top, we are looking at TensorBoard, but the TensorBoard the content will be created later. When BP is prepared, it goes to training stage. So basically it's a pipeline, as the name says. The first one is preparation, second one is training, and the third one is evaluation. So the configuration is designed in a similar way. The preparation stage, it has to do BPE with some vocabulary types we have mentioned. And then there is a training stage where it is going to train. Then it goes to testing stage. In between, in the training arcs, we have checkpoint. So after 1,000 steps, it will take a checkpoint, meaning it will validate and then report the score. That is when we will see some activity in the TensorBoard here. So right now it is still in the training, in the preparation stage. It's learning BPU vocabularies. And since it's collab and we don't have too many CPU cores, some of the stuff is going to be very slow. Some of the things that require CPU is going to be very slow. So as we've witnessed, the tokenization, for example, runs on CPU, it is slow. And BPE algorithm runs on CPU, that is going to be slow. So we just have to sit and watch. Now it's going to prepare, it's going to encode training data with the BPE model. That means convert all the strings words into integer sequences. And later it will be faster, so it doesn't have to keep doing that again and again for the training data. And as I mentioned, because it is running on CPU and we have a 2-core CPU, it's going to be slow. I've been keep repeating it. So how is it so far? Did I bore you all already? It's boring. Okay, this is still working on, but if we look at the experiment directory, we see some activity. For example, it has created data. In that we see it has created BPE model, and it is creating training data, which is currently of size 1 It's not showing size now. So there is some logs. Okay. I wish I'd done it on a other system where I could look into it in real time and then see how that's going on. I believe this is supposed to be a some kind of progress bar here, but I'm not seeing it here. Okay, um, there is nothing we could do. We just have to wait. Let me go and clean up the notebooks. Debugging CUDA setup. As you see, I used to face a lot of issues before just to get CUDA working. Um, Now we don't have to. So kudos to NVIDIA and PyTorch people for resolving this. I kept it up. We don't need that. I don't need that. I don't need that. I don't need that. Okay, we are already at the end of notebook. So the nice thing about this is we took some time preparing the configuration file, but once we have it, we can just run one command and then go home. It will take some hours to train the model. Then you have it. Whereas other frameworks, you will have to wait for it to finish and run the next command, next command. So everything here is written, configured to be a pipeline. So it's designed to be a pipeline with just one push, one button push. So meanwhile, while it's going to do the pipeline thing, let me show you some aspects of documentation. So here we have one config, but there must be one more section where it is called CLI. Yes. So the RTG framework comes with RTGPipe, the main one that we are just using. But for whatever reason, you would want to not use pipeline. Maybe you want to go stage by stage. As you see, there is RTGPrep, RTGTrain, RTGServe, RTGDecode. You want to decode Pro with a lot more options. So we have all this. But currently, we ran this RTGPipe, which we'll call this module. And here we specify the experiment directory, which is required. And conf is optional. It will automatically pick conf from the directory. So that is what's going on. Next step is once we have trained the model, we should be able to decode it. We should be able to, let's say there is a new evaluation set and we want to decode that set, then we have a translate that. For historical reasons, we call it decoding. So we call it our RTG decode. So that command takes input file and it will ask where to store the output. Then batch size, and of course experiment directory where the configuration models are stored. Then it will produce a decode. I think we will use it after the model has finished training it. Let's see where it is. It is still in train. I'm going to cut the video here and maybe resume it later. Okay, I am back. I think there is a crash. I knew what was going to happen, but I just wanted to show you that this is real world. It's going to happen. So there is an exception. It says config value prep dot valid target raw is required. It should have a path to file having raw unmodified target file to be used for computing blue. Okay, so if you remember our previous modification of the config file here, we just followed the example, and it is, even the example configuration is somewhat outdated. There is some new requirement that we need to include. So let's take a moment to understand this exception. The exception is saying that config should have a value. Inside prep, there should be something called valid underscore target underscore raw is required, and it should be a path to a file having raw unmodified target file. So to compute blue. Okay, so we don't have that in our config. Here is the printed config. We see that there is valid source, which is a tokenized one, validation target, which is a tokenized target dev validation, but we don't have valid target raw, which is required to calculate the blue score. So I'm going to add that here as requested by that exception. Going to repeat the target validation target side data, but that was tokenized. And here I remove the dot token. So here it is without tokenization. And this is a raw file. And now we should be able to calculate our blue score against this file. And that is a reportable blue score. Okay, so usually people don't do that on validation set while tracking, but this is a feature built into RTG where even the blue score report tracked during the validation is also a reportable blue score. Okay, so I updated the config file. Now I'm going to print it again. Then I see if that file is available, valid underscore target underscore draw. Yes, it is available and it is pointing to the correct path. Now let's scroll and then start the pipeline again. So the nice thing about RTG is it's going to resume from where it was left previously. So previously, if you remember, it was doing BPE encoding, and then it was learning BPE vocabulary, and it was encoding training data, that is converting all the strings into integer sequences. So it has already done that. Now, good news is it should not be doing it again, even though there was a crash, and I'm restarting it. Let's see. Yes, it is not doing that. Already prepared, so it skipped the preparation step. And now it's going to train the model. Early stopping is not enabled. Some warnings. Okay, great. Now, CUDA device does not support B float 16. Please switch to float 16. Okay, so there is this CUDA device does not support B float 16. That is float 16. Please switch to float 16. That is weird. I don't remember using float 16. Okay, this is probably an older CUDA device, and I tested this on newer CUDA device, and now I'm gonna take some time to fix this, or downgrade RTG to the older version. Okay, so I will have to fix this on. I'm going to create a issue. First thing to do is reach out to the RTG developers and ask if there is something they can fix, which is going to be me. Okay, so I guess there is some code I recently changed is not going well with this old GPU they have given. I will have to support the old GPUs. So now what else I can do is downgrade to the older version of RTG. How do I know which version would be the immediate older version? Well, we go to PyPy, project, RTG, and then we see release history. Then we see that 0.7 was released, but 0.6.1 is what we need to, is the immediate old version. So I would do pip list grep RTG. We'll see which version it is. Ooh, it's not even showing version. Okay, regardless, I'm gonna install, force install. Oh yeah, I can do this. Hopefully, it should show my version. Yeah, it is 0.7. So I'm gonna do pip install RTG equal to, it must be double equal 0.6.1. Okay, let's try that. 0.6.1. Okay, downloaded it. It is uninstalling 0.7 and install 0.6. So that's good. Now let's try RTGPipe -v. So let's do that. Okay, now it's 0.6.1. Let's try to run it with just an older version of RTG. Okay, there you go. It is now training. So what do we do when we have an exception? Well, you see if there is a problem with if it's your problem or the system problem. Now, in this case, it was the newer version of RTG is not compatible with some older GPUs because I switched from float 16 to B float 16. I reported that problem to RTG GitHub. So, and downgraded to a version before that because, well, that was the right thing to do here. Because the GPU is somewhat old, it does not support some new features. But the older version of the code must be happy with the older version of GPU. So we see it is now training. How do I know that? So here we see it is training. It's gonna take 3 hours to train, roughly about 3 to 4 hours. We should be seeing it here. Okay, I think it will get updated eventually. We may probably need to wait until the first checkpoint to see some data in TensorBoard. And the first checkpoint happened at 1,000 steps. Okay, so time to go get another coffee because this is going to take some time, right? No way I'm going to stand here and record a video for 3 hours.